taking a closer look at what I think the problem is with the AM Superhet receiver. Good Saturday afternoon to you all, YouTube. It is about 1:40 now in the afternoon. I am sitting here in the on the workbench, or at the workbench, I should say. If I sit on the workbench, it might collapse. Nothing has changed since I did the video on the updates, and all the things I have changed is basically I checked to make sure that the diodes were in correctly, and they are. And I think what I'm going to do is to attach this clip here to that terminal there. That's the second diode on its. Let me show you on the. If we look here, that's the two diodes are somewhere. They're there. That would be D4 at this end is where that's at. So that's going to be. I'm ahead of the 10K resistor. I'm here, but you'll see the same action there as you do here, just more or less pronounced, I guess, is what I would say. In other words, the effect of the thing is going to be the same no matter if it's there or after the resistor. It's just going to be a little less shown on the meter, which you guys can see the meter up there, I think. And if I haven't put that shot up yet, I will. And see that. Now we're going to hook up the other lead to this, which is the one for the voltmeter, and that just goes right on ground. Make sure I got a good connection. Now nothing is on yet, so don't have to worry about that. And the other lead that I just hooked up here is going to hook up to the positive of the. You'll notice the meter is fluctuating as I move this lead around. Alright, it is hooked up now. Alright, now let's turn this on, and we should see a movement on the. Now the signal tracer is already hooked up, so let me check my shot with my mirror here. Yeah, we're in pretty good shape there for that, and I'll leave that out. So alright, let me turn this on, turn this up a little, and adjust this a little bit. Now you can see right there, there's virtually no signal. I have the what do you call it, up. I have it connected where it should be connected, and I have the radio on. Like I said, there's a little bit of a noise there, but not much. So let's adjust this. You can hear that when what happens when I adjust it. I'm going to put my finger right there to hold that down. Now we're on the low end of the dial. I'm trying to let my finger not adjust it too much, but every time you hear a signal, you see the meter goes up. And we're on the 1 volt scale of that. So now for anybody who was doubting the fact that this voltage is going up, I just wanted to prove it to you. So that is opposite the way it should be. Now there's no signal there. You can see, you can hear the stat of the clear. I'll put it back on the signal. Maybe. See, that's the thing I don't understand. I just went through there and it hit. Maybe I was touching something I wasn't supposed to. Okay, there we go. Alright, you can see the point I'm trying to make here is the fact that with a signal, when you hear that signal, and it doesn't matter about the signal, it doesn't have to be a radio station or anything like that, but you see what happens. It goes up. Okay, that's all the way to the other end. Now my feeling is that's probably a radio station. The local station, as a matter of fact. But there you can see, it just appears to be going the opposite way it should go. And that's my only point in this video. Turn it off, you see it goes down, and turn it back on, goes right back up. So obviously the let's turn, you can hardly hear that. I'll turn it up a little bit, you can hear it a little bit there. So there you go. If I go all the way down, it seems like it goes away, but it comes back. That I don't know what it is, but it's obviously something that's not a solid signal. It's a pulse type. But that's clear as bell. It's going up each time something gets a little stronger. Alright, that's going to do that. Let me shut this down and talk a bit. Like I said, it's just not really sure why it's doing that. I don't know. Let me rearrange cameras here and see if we can show you exactly how this is wired up. Alright, now there you can see, I think, let me get a pointer, clearly that this stripe right here, this black stripe, and if you look where it goes through the board right there, it connects right here to, this is I believe pin 4, and I'll flip this over a little bit so you can see that. But you have the pins here on the, I believe that's pin 4, and well, actually that was the diode. Okay, I believe this is pin 4 here, and so that would, the other pins of the, there you got 1, 2, 3 or whatever it is, and it comes out 4 here. But I believe that's pin 4. That's where it's supposed to connect. We'll put it that way. But you can see clearly that that goes into the pin 4, and that's the striped end, the cathode. And it goes through there and comes out here and goes around to the other one, which is laid out exactly the same way, and they are joined under here. And it is also striped towards the IF can, and then goes out. This is where I was picking up the signal at, was right here on the end of that, right before this diode or resistor here. So, or actually this resistor here, the 10K. So, you know, if you go after the 10K, that's where the actual AGC voltage is located, but you get the same action up and down here as you would there. I don't think there's any difference in that. I could have probably got to it, and it's just a lot easier to get a hold of that metal ring out of there on them little clip leads or hook leads that I was using. So that's how that works. Now there's our our audio or positive audio coming out, and the negative just connects. I was just connecting to the base or the bus bar under here, which connects to that, and that's how that was all wired up. But anywho, that's and again, let me show you this on the schematic. Let me get back out of this if I can. Yeah, here we go. This would be, like I said, pin 4 of that third IF. The other end goes to ground, which I'm pretty sure it does. But that comes out of there. You see there's the band on the diode, and with the other one wired just exactly the same. Goes through here and goes through this 10K. Now I was connected right here instead of here, whereas it says AGC. But like I said, the AGC is that was just, I guess, to limit the voltage just a little bit. But it, like I said, it was connected there, and it was going up, and it's obviously going to go up here the same way as it did there. Now the AGC is also connected over here to pin 4, and it goes to the mixer. In other words, it goes into each of the stages to control the gain. And like I said, it goes there, and so that's the way that works. And the idea is the stronger the station, the less voltage is being fed into the amplifier, which is the transistor. So if the signal gets stronger here, this AGC is supposed to knock it back down to a reasonable level. And that's the way the AGC functions, or ABC, whichever one you call it. And that's how that's supposed to work. Now, obviously, if this has got a strong signal and this is feeding in stronger voltage, that's going to overload this. And that's what I fear is happening. And I think that is our problem altogether. And so, anywho, that's, like I said, is the way that's going to work. Now, not really sure, and I don't know that it matters a lot, but this is marked with a bias instead of the AGC. Now it's the same setup as this. In other words, it goes through the transformer to limit the amplifier, the transistor. And now this one's just fixed here at the V bias, which comes up and does that. So there's no actual adjustment here, which I guess is okay. I guess that's just the way the circuit's set up. And like I said, there's a constant voltage here. Whatever gets through here, I guess, is, you know, amplified by that the same no matter what. So I don't know. Like I say, usually it's all stages, I think. But even like I said, this one goes all the way down to the mixer, and it's supposed to adjust the gain of that. So that's my problem, and I think you can see it clearly now, or you know, you should be able to see it clearly. And so, you know, that's what's the solution? Now, the way I understand it, the voltage is developed because of the polarity of the diodes. Now, what's to say reversing those diodes would not reverse the polarity? That's my question. You guys are smarter than me out there, and there are many of you. I just want to make that clear. I am not the most smart person on the world when it comes to stuff like this, because I can assemble kits. I can put things together. And now my theories on my tube theory, things like that, is pretty good. But you know, again, I didn't have a lot of instruction on solid state stuff either, and so, you know, I just know, you know, what it's doing. I can see, you know, if I put that lead on there and measure the voltage, it goes up when the signal goes up. That's, you know, that's easy enough to see. So my question is, if I reverse these diodes, will that reverse in other words, make it a negative voltage? And so I'm putting that out there. You guys let me know what you think. And that's going to do me for now, because that's all I really had. I just wanted to trying to get this to work, and you know, you heard on the one video I did, there was definitely something there, some kind of words coming out, and I believe, like I said, as soon as I was getting, you know, the audio out, that it was overloading the circuit and then going away. And I think that's what's happening. And I think it's just too much for the little 3904 transistors, and I think it just doesn't work anymore. So that's my feeling on it. So like I say, you guys let me know in the comments, email, whatever you want. Yeah, I'm making sure I got that all. Yeah. Anyway, like I say, you guys have a wonderful, wonderful day. Thanks so much for watching, and we will see ya.